First of all, Skylar said, okay, what is that 14% again? And she said something. She's like, is that the percentage of agreement between my data and the null hypothesis? And I said, hell yeah, it is. It says, assuming that there is no difference in the commercials and the shows, there's a 14% chance that my data agrees, which is obviously more than the 5% unusual definition that we set in place. But her point is, I don't think that's small enough. She would want that to trigger, you know what, I think, they are louder, yes? It's a positive number of standard deviations, which means they are louder. They're just not loud enough to be statistically significant. Is that a fair statement?
Yep.
So what you could do at the beginning of a study, not now, because you're not allowed to change your confidence after the fact, because that's bad statistics. You might say, well, let's just lower our confidence to say, oh, I don't know, 85.58%. Because that would make that significant, wouldn't it? If I drop my confidence low enough. It would make that significant, because that would pull this down, and that would then be outside of that range. You can't do it post-fact, but you can do it before. Now, if you do that, if you lower confidence, you are increasing the chance of a what? Boom! You are increasing the chance of a type 1, but you're also decreasing type 2. So for those of you that thought type 2s were worse, that might be the way to go. Pull it back. Say, if I don't like a type 2, this is before the fact, Andrea. Before the fact. This is not after the fact. Please, YouTube world.
Say that's shady.
No, it's not. Not before the fact. It's not before the fact. If you care more about a type 2 than a type 1, if you can live with the consequences of a type 1, there's nothing wrong with that at all. And remember, this is statistical, not practical significance. Mathematics only. Mathematics only. Not trying to steer a study. The best thing to do across the board is always what? Always what? To decrease both types of error. Oh! That's the second question I wanted to answer, which is, remember the original hypothesis is not equal to 0? Watch what happens if you run the test two-tailed. Now some of you might already know, without even me running this test. I'm going to turn my graphs off because they're getting kind of annoying, huh? Okay, t-test. Change everything except, or leave everything the same except the hypothesis is now does not equals. Try to predict what's going to happen as it happens. Boom! And what's your p-value? Double what it was for a one-tailed test. That's because the test statistic is still the same. It has to be still the same. It has to be still the same. It's the same data. You haven't changed anything. It's still x bar minus supposed mu over standard error. But because you picked a two-tailed option, it says it could have just as easily have been on this side as this side due to randomness, which makes it harder to get a significant result, which is why a lot of statisticians like it. It's a higher proof of burden. That's why a lot of statisticians like a two-tailed test. What's the key word to look for if I'm going to ask you to run a two-tailed test? Look for the word, well, different, if you don't mind. Because we always have to do a difference with a matched pair, but we're looking for the fact that the average is different than 0, as opposed to louder or quieter, which implies a 1. Is that fair? And that's probably the English language getting in our way right there. Fair? Third question, a fantastic one, Lauren. She noticed as she was scrolling down through her menu that there's a 2-sample t-test option, isn't there? There is a 2-sample t-test. And this looks like it might be a 2-sample, but it's actually, go ahead.
It asks if your data is pooled or not.
Good. Go hold that. I'm going to hold that, if you don't mind, till Wednesday, because there's a reason it involves V-breaks on my cyclocross bike to actually explain that better, if that's okay. But the thing is, this isn't 2 samples. It's 1 sample. It's a sample of differences in volume.
Because the data is only the 1 and the -2.
Yes! Your data is that L3 list, which is the difference. It's actually only, if you do the 2-sample, you're actually creating that loss of confidence.
So couldn't we have
But we can control for that, and that's why it sort of take longer time today to get into that pooled idea versus non-pooled. But we can control for that loss of confidence mathematically, which I want to get into next time.
Could we have just made the L3?
From the beginning?
Yeah.
For sure!
Okay.
Absolutely. I mean, I want to think.
Why are we doing this? Can't we just subtract this?
Right, but it's not always clear as to why you would do that off the bat. Does that make sense? I mean, you can totally do that if you want. But a lot of times you collect the data individually and then you have to subtract it after the fact. You got to realize I'm handing you data sheets, which is great. but that's a little bit fictitious. 99% of your effort is usually collecting the data yourself, which we're about to do in the next exercise.
Well, I mean, when you're entering the data.
Oh God, yeah, you can just go ahead and do, yeah, but remember sometimes they're ugly decimals and they're ugly numbers. You don't want to, let the technology do it for you. This was nice in that it generates pretty sweet data. Fair? Decent? Good, maybe. Good? Any questions we have right now? As you think of them, hand these around. I got stopwatches. Hopefully we have enough for everybody. Yeah, cool.
My question was when we eat the lollipops.
Oh, whenever you want.
An hour and a half ago I said grab a lollipop if you want one.
You might be.
You had your hat on, you couldn't hear me at that time.
It's because it's damn commercials.
I'm sorry, I'm fuel.
I don't want your eyes.
This is because I wouldn't eat your damn M&M's from last whatever the hell you brought. Eat. I don't know if they're going now. So let's have the class. Coincidence?
Wait a second.
Nope, poison them with her.
I don't think we have to, unless there's not enough stopwatches, in which case maybe.
There's not going to be enough.
There's not going to be enough. Okay, maybe we pair up then. Yeah. Or if you have them on your phone, if you have a stopwatch on your phone, I wonder if we can do the maybe. Let me paint the picture and then we'll decide if we can do that or not. If not, we'll just do with what we've got. But let me see if we can, let me describe the situation and then you can decide if we can use the stopwatches on the phone or not. And here's why. Anybody have any questions about the decibels? Oh, speaking of which,
Can we turn it in as a quiz?
we totally can, for sure. This is the one you want to do? Yeah, absolutely.
Sure.
I want to chit-chat a little bit, though, about the results of this. And it's funny that even, oh, Brandon, if you don't mind killing the lights real quick. It's funny that this was even admitted in a report. As we just, there might not be enough. There might not be enough. What's interesting, check this out. Check this out.
Oh, yeah.
There is an audio tool called compression. I don't know if anybody's ever heard of this before. Guitar players use it a lot in studios when they play a guitar chord, or if they play a bunch of guitar chords or a bunch of little individual notes. Sometimes their individual notes vary in intensity, and you don't want that. It sounds stupid when that happens. You want to have the same intensity level, especially if they're playing like staccato notes. So there's a tool called compression that sets a baseline below which the sound can't go. And if it is below that, it'll boost it up to make it match that lowest level. So in other words, it decreases the variation. It makes it more precise, if that makes sense. That's what the commercials do. If you think about it, and this is a graph, I found this graph online. I've got it sourced out somewhere on here. But what they do is they boost the lower levels on the commercials and raise them, but they keep the max level at the commercial roughly the same as the max level of the show. Which means that would explain why we got the results we did in our test, yes? On average, the maximum volume is no higher than the maximum volume of the commercial. But what might be different, not the max level, but or maybe the minimum, good, or I was thinking more like the average, but yeah, maybe the minimum level is higher.
Or you get loud all the time in commercials where in TV there's variance.
So maybe you should check the variance of the volume in the show versus the commercial. Good, I like the mid-level too. So I did a little more digging. FCC adopted the rule, commercials cannot be louder than television shows anymore. Okay, that's that issue we have with the wording. What does that mean, louder? The rules adopted today require that commercials have the same average volume. Average volume. Have fun measuring that.
Yeah.
How are you going to measure the average volume of a TV show?
Well, their sample size of the commercial time is so much shorter than.
Now, so the problem is you've got like a 30-second commercial and you've got a 5-minute segment of TV.
Yeah.
Now what you could do, of course, is use the dB meter and leave it running and have it collect data every 5 seconds, for example, and then use that as a sample. I mean, you could totally do that. You could expecting to have sampling error, obviously. I don't know how to do that. I don't have the tools to do that right now. That's one way to do it, though. Yes, Mike. What are you thinking of?
Oh, it's just like, potentially then if it's just the average, they can make it quiet for half the commercial and then just boost the noise up for half of it too.
If your head's in the oven and your feet are in the fridge,
Use your outliers to
you're
your
fine.
advantage.
yes, use your outliers to your advantage. Make the outliers balance each other. Come back to center. Good. Bad statistics, but a good use of mathematics. Good.
Well, this isn't statistics.
This is Congress.
commercial people trying to find loopholes.
This is a logical thought. This is what government.
Yeah.
Yes. So and again, TV commercials could not be louder. Could not be louder. So I just found it very interesting that it's consistently said, passed down, but not measured and not being able to be defined. Which is very, very interesting, I think. I think it's a tricky thing to talk about. So anyway, I will collect more data eventually. I'm going to look into these apps for the phone and see if I can get if I can tolerate the accuracy loss. Then we can get some new data. Fair enough? Okay, I think we've killed this idea. Let's bring one closer to home, and you guys can decide now. How many people have stopwatches? Are they all out? They're all out. Yeah.
Have them.
Oh, you all have them?
I didn't, if you don't.
We got one more back here. Yeah, and the reason I think we should, thank you, Lauren. The reason I think we